Alrighty. So here on number 9, I have 1 minus cosine 2 theta over sine 2 theta. So you almost always want to get rid of your double angle stuff. At the end, it might come back to a double angle, but depends. All right, so let's try to think about some things. And again, I know that they're still pretty fresh to you, but in the denominator, I'm going to have sine of 2 theta. All right, that one starts with a 2. Anybody know what comes next? Sine theta times what? Cosine theta, okay? So this is one of those that you have to know. Now, if you don't just straight up know it, then you can get to it from the sum and difference angle ones, but it's kind of up to you. Do you want to know how to figure it out every time, which might be what has to happen at the beginning, but then once you use it some, maybe you just have a way to commit it to memory. Then we have cosine 2 theta. Now, cosine 2 theta has 3 different versions, okay? And whether or not you know all 3, you can just go with the first one. So we're going to do 1 minus. So let's just do like the actual cosine 2 theta that you would come up with if you were to figure it out from the sum identities. It's the one that looks like the Pythagorean identity but isn't. And since it's cosine, it starts with cosine. And since it looks like the Pythagorean identity, it has a squared in it, and it has a sine squared. Pythagorean identity, we add them. So when this is not actually it, we subtract them. And that's your cosine of 2 theta. Again, you have a way of remembering it, or I will, like I said, we will go back through and look at how to develop those again. Because I know when I did that on day 1, everything was new and weird to you. But I think after seeing this a little bit, then you'll be okay with, it'll make a little bit more sense when we do it again. All right, so now I want to clean this up a little bit. So my denominator is going to stay the same. 2 sine theta, cosine theta. And then I'm just going to distribute that negative, so that'll give me 1 minus cosine squared theta plus sine squared theta. Now, can I reduce anything at this point? That will be a no, a big fat no, because there's addition and subtraction in the numerator. I could split the fraction, but I don't think I want to do that either. What can I replace 1 minus cosine theta with? Sine, right? Because remember, sine squared plus cosine squared equals 1. So 1 minus cosine squared is sine squared. So sine squared theta plus sine squared theta over 2 sine theta cosine theta. And then what is sine squared plus sine squared? 2 sine squared. So we get 2 sine squared theta over 2 sine theta cosine theta. Can I cancel some stuff out now? I got no addition and subtraction, so that's great. So the 2's cancel out, and I can cancel this sign out with one of those. So that leaves me with sine theta over cosine theta. And what is sine over cosine? Tangent. And we're done. Okay? Like little puzzles. Okay? We all good? Let's look at 10. All right, so this, the way it's written out, kind of looks like a sum or difference identity. Would you agree with that? Okay? Since it starts with sine, is it a sine or a cosine one? Sine. Okay, if it starts with sine, it's sine. So I have the sine of, okay, and then these are my 2 angles. So I have pi halves and alpha, and then I just need to decide if it's plus or minus inside of there. Since these 2 change, does the sign change? No. When this changes, the sign does not. If this was sine, sine, then it would be plus. So this is minus. That is one way to simplify that identity, okay? But that, again, you have to kind of know your sum and difference to do that. Another way, and really it kind of depends on how the question is asked. And if it's multiple choice, you'd be able to tell from the answer choices, I think. I can also not worry about the fact that it's a sum or a difference identity at all. And I have sine of pi halves, like that's a value I know. So if you have angles that they put in there, then actually find these trig values. So what is the sine of pi halves? 1. So this is going to be 1 times cosine alpha minus, what's the cosine of pi halves? 0. So that's 0 times sine alpha. Then when I simplify that, 1 times cosine is just cosine. And then 0 times sine is 0, so that's my answer. Okay. So these are two completely different answers. This, I think, is more what we're trying to go for. But the fact that these both mean that the same thing, like basically all three of these things are the same, this is just a horizontal shift, right? And isn't cosine just a horizontal shift of sine and vice versa? That's why those two end up having the same value. What questions you got? All right, let's look at number 11. Do I have anything I can factor out here? Do I have a GCF? Tangent, very good. At this tangent squared, y that I can factor out, that leaves me with 1 minus sine squared y. Okay. What can I change 1 minus sine squared to? Cosine squared, good. So that means I have tangent squared y times cosine squared y. Then can I rewrite tangent? Yes. I can rewrite tangent as sine squared y over cosine squared y times cosine squared y. Then can I simplify? Yep. I can cancel those out. That leaves me with sine squared y. What questions you got? Okie dokie. Let's look at 12. So I have 2 tangent theta over 1 plus tangent squared theta. So we split a fraction on Friday. I can't split this fraction because I can split a numerator. I cannot split a denominator, so don't start making up math, okay? Yes, I can make tangent into sine over cosine, but I think I'd like to do something with that denominator first. So I'm going to leave my numerator like it is. 2 tangent theta over, all right, so can I replace 1 plus tangent squared with anything? Secant squared, very good. And that's written on the front of your notes. And no, you're not going to have a reference chart, but we already wrote it down for a different question. And so if you already have them all written out, then they're there for you to refer to for yourself. All right, so now I want to simplify this. Well, I can change tangent and I can change secant, so everything's in sine and cosine. So that 2 tangent theta could be 2 sine theta over cosine theta over, and then what's the reciprocal of secant? Secant is cosine. So this is 1 over cosine squared theta. So I have a fraction and a fraction, and I know none of us like the way that that looks, but it's not as bad as it seems. Exactly. So we just keep change flip. 2 sine theta over cosine theta times the reciprocal of the denominator, so that becomes cosine squared theta over 1. Can I reduce this sum? This cosine with one of those, so this gives me 2 sine theta cosine theta. And that looks like something we've talked about before, right? What is 2 sine theta cosine theta? Sine of what? We used it, I think, in this one. It's sine of 2 theta. We're done. Okay. What questions do you have? We all good? These things will start looking more familiar to you the more you do these and the more you're looking at the things that you have to know, okay? Just take some time. All right, so let's look at the assignment. Okay, so number 1, the numbers are nasty for absolutely no reason, so we're going to mark that one off. Number 2, I intended to mark off because we don't need to know the tangent ones, and I forgot. So the tangent of the double angle and the sum and difference, we don't have to know those. So you're going to mark off 1 and 2. You're also going to mark off number 6. Okay? And then we're going to go back and do number 3 together. So 1, 2, and 6, you don't have to do. All right, so when I look at number 3, I have this all written out. Looks like one of the sum or difference identities, right? And if I could actually if I knew the sign of 4 pi ninths, then I would put that, whatever that number is in there, just like I did for the sign of pi halves on the other one we just looked at. But I don't know those, okay? That's not something you're expected to know. Instead, I see the pattern for a sum or difference, so I'm going to write it as a sum or difference. First of all, would this one be a sine or a cosine? Sine, okay? So I'm going to have the sine of, and then my alpha would be 4 pi ninths. My beta would be 11 pi ninths. And would I be adding or subtracting these? Sine is the same. Cosine changes, okay? Sine is the same, cosine is not. Then, these two angles, I can actually add them together. I couldn't on the last one because I had a number plus a variable, but this gives me the sine of 15 pi over 9, which is also not a value that you necessarily know, but can you reduce that? Yes, and that would give you sine of what? 5 pi thirds. Is that a value you know? Yes, it should be. What quadrant is 5 pi thirds in? Fourth, okay, and in the fourth quadrant is sine positive or negative? Negative. All right, and then what is the sine of pi thirds? Square root of 3 over 2, and then that's your answer. So that one we got an actual value instead of ending up with cosine alpha or whatever it was, and we end up on the other one. Okay? So it kind of depends on what information you have. But all we did was use this pattern to put it in here and simplified things so we got it down to something we could actually work on. Okay? That help? We good?